9.12, Chapter 9, Section 12, Problems involving the sine and cosine rules. Summary. So these are just a summary of the sine rule. A over sine A equals B over sine B equals C over sine C, or the inverse of those. There's your triangle. Cosine rule. A squared equals B squared plus C squared minus 2BC cosine A for the length of a side. For the angle, it's in this form. They're the same formulas, right? This is just rearranged to have cosine A on the left-hand side. And there's the diagram that accompanies that. Don't forget the angle we're talking about is in an included angle between the C and B. So A is an included angle between C and B. Example 25a, find the value of k correct to one decimal place. That's k. So what are we going to use here? It looks like we can use the cosine rule, right? We come down here. The problem involves three sides and one angle, so use the cosine rule. Because we have an included angle, we have the left side, we have the right side of that included angle, we don't know the opposite side. It's a classic case of the basic cosine rule of A squared equals B squared plus C squared minus 2BC cosine of A. Okay, let's look at the diagram. You notice that's kilometers, kilometers, and then meters for some reason. They've gone to meters here. So it's a mistake, I guess, because they've still got this as kilometers. So let's change that to K kilometers. That should be KM. Let's do that. Okay, so we've changed that to kilometers. And that should be kilometers as well there. We'll change that in a minute. Okay, so it's just K squared, the opposite side squared, equals 8.4 squared plus 12.9 squared minus 2 times 8.4 times 12.9 times the cosine of that angle. That should give us K in kilometers. And there's our answer there. It looks like 8 kilometers. Let's change that M to a KM. Okay, so that's 8 kilometers. Question B, find the value of theta correct to the nearest minute. When you look at a triangle and it's not a right angle triangle, if you have an angle and you have the opposite side, think about the sine rule before you think about the cosine rule. Well, this is a good example for the sine rule because we do have an angle on the opposite side. We have an angle we don't know and we have that opposite side. The problem involves two sides and the two angles opposite them, so use the sine rule. Now, sine theta over 8 equals sine 57 over 9. Familiarise yourself with it over here. Now, they've flipped it the other way because the unknown is sine theta and they prefer that on the top. Remember, A on sine A equals B on sine B equals C on sine C is exactly the same as sine A on A equals sine B on B equals sine C on C. So they've put it this way. That way all they needed to do was cross multiply with the 8 or multiply both sides by 8 if you prefer, and they get sine of theta equals that. Then that theta equals this as a decimal. They asked it to the nearest minute. The way to get that to a minute is that's 0.2007. Multiply that by 60, and that'll give you the minutes in decimal. And then the decimal portion of that, you multiply that by another 60, and that'll give you the seconds. And then you need to round up to the nearest minute. Exercise 9.12, I'll give you some solution hints here. Problems involving the sine and cosine rules. Find correct. Now, this is where you have to decide which one you need to use. Now, my advice to you is the first thing to do is to recognize that it's not a right angle triangle. These are problems involving the sine and the cosine rule, so they probably didn't give us any right angle triangles. But remember, always look for this to try to use the sine rule before you use the cosine rule, because the sine rule is a lot easier. 1. Find correct to one decimal place the value of each pronumeral. So the first thing we do is we think about the sine rule. And it looks like we could use the sine rule, right? We've got an angle on the opposite side, we have an angle and we don't know that one. This one here. So this is a classic case of the cosine rule because we have an angle, it's included between 27 and 16, and we're going to find the opposite side. C. First thing, think about the sine rule. We've got 47, we've got 12.8. Well, that's very, very good. That's an indication that we could probably use the sine rule here. There's a 56 and that, but the problem is we've got to get this y, and we don't have that angle, or do we? All we have to do is that angle is 180 minus that. So then we can use the sine rule because we will have this and the opposite angle, and then we can find that because we know that a triangle has 180 degrees, and so we can find that because we know the other two, and then we can know that angle, we could find that. So that's a sine rule one. D, this one here looks like the cosine rule. We've got the included angle, and we need to find the opposite side. E, over here, again, it looks like the cosine rule. Okay, it's in minutes. Be careful of that. Okay, that's 78. It's 47, so it's probably 78.7 degrees. Make sure you recognize that's in minutes. You put it in a decimal if you don't know how to use minutes and seconds for degrees in your calculator, but that's a cosine rule. This one over here, first step is to think about the sine rule. We've got an angle, and we don't know the opposite side, and we have an angle, and we know the opposite side, so that's a sine rule. Question 2, find the value of theta to the nearest degree. Use diagrams to note whether theta is acute or obtuse. Okay, when you use the sine rule, remember, always check for the sine rule first. If it's a sine rule question, make sure you're familiar with the ambiguous case. Go back and have a look at that video and see how you would find out whether two solutions exist, an acute and an obtuse angle. Okay, and then when you come to these ones here as well, you can work your way around to that theta. You know that and that. You could find that. Okay, so once you find that, you can add them together and subtract them from 180, and that should give you theta. Keep an eye on acute and obtuse, though, with these. These two are very similar to the example in my video on the cosine rule for angles. Question 3, the angles of elevation of a building measured from two positions 80 meters apart are 32 degrees and 55 degrees, and they've given you a drawing for that. The two positions are 80 meters apart. We want to find the height. Now, to work our way around to the height, explain why that angle ATB is 23. They're telling us that ATB, that is 23. Okay, think about it. Okay, how could we find that or confirm that's 23? Think about this. We would need to know that first, maybe. That could be the first step to find that one. Do we know that angle? Once you find that angle, 180 minus that should give us that. B, find correct to two decimal places the length of BT. If we need to know BT, well, we have an angle and we know the opposite side. Remember, we got that in A. We know the opposite side. We have an angle. We could get the opposite side. We could find that. And hence, using that information from previous parts, we now know BT and we know that angle. If we wanted to find the height, we could use one of the trigonometric ratios. Question 4, what is the value of sine 90 degrees? Well, think about the unit circle, and that should be a little bit easier for you now. Use the unit circle for that. Find correct at one decimal place the value of D using the sine rule. Got to use D using the sine rule. It's a right angle triangle, right? The sine ratio for the right angle triangle. So you could do that pretty straightforward. What do you notice about your results? Give reasons. 5, Michaela needs to run around a cross-country course as shown. What is the length of the course correct to one decimal place? This looks like a lot of fun. You know the occluded angle. You need to know that length, and then you just add up the perimeter. Okay, question 6. A plane flew on a bearing of 150 degrees for 370 kilometers. It then changed direction and flew another 285 kilometers on a bearing of 235 degrees. How far correct to the nearest kilometer is the plane from its starting point? Perfect IB type question that you could find in the diploma program. And what you need to do first is draw the diagram and have a good understanding of your bearings as well. But it's a great question, and they often combine these kind of cosine rule. I'm not sure I think this would be a cosine rule one, a cosine rule and a bearing one. So when you get it done, choose whether you're going to use sine or cosine. They're generally cosine, but see how you go with it.